Hi everybody, in this video I'm going to talk about the first set of problems that we want to use for the quiz for the dynamics. So we're going to just go through the selected problems, not every single one. Number 2, let's start with number 2. Okay, number 2 talks about a block sliding down a plane. And one thing we haven't really emphasized but needs to be emphasized is when you draw this, which one's longer, basically. And you are making a right triangle out of this where your hypotenuse is the gravitational force, the weight, basically. And so the other one, the one on the top, kind of looks like this, where the normal force is equal to this leg. I'm going to zoom in a little bit. So the normal force here is equal to the leg here, and the force of gravity is the longer one because it is the hypotenuse. So just remember that that is your hypotenuse, and when you draw this, make sure that you're including that to be your hypotenuse, and the normal force then is just a leg. Okay, so the question was a 2 kilogram block slides down a 30-degree incline as shown with an acceleration of 2 meters per second. Because it is a 2 kilogram block, then the force of gravity, or the weight in this case, is 2 kilograms times negative 10 meters per second squared. And so this is 20 newtons. So again, when we go up to the top then, the normal force is not 20 newtons. The normal force is less than 20 newtons. Okay, let's just go back to the diagram for a minute, or question number 2. So which one represents best? Well, the weight has to be acting downwards. So that's the first thing I'm going to look at. This one's acting down, this one's acting down, this one's not, this one's not. So it has to be one of these. And I know the normal force doesn't act that way. And so D is the option. Now question 3 continues on with the same diagram. So which of the following indicates the magnitude of the forces acting up and down the incline? So what's acting up and down the incline? Well, we have friction going up the incline, and we have the actual box going down the incline, and it does say it's sliding down the incline, so it is going down the incline. If it is going that way, and has an acceleration in that direction, because it's going down the slide, the ramp, then the sum of the forces going down the ramp has to be greater than the sum of the forces going up the ramp. Otherwise, it wouldn't be moving or it'd be going up, which isn't happening. So it's going down. So I know the sum of the forces going down has to be greater than the sum of forces going up. So as I look at this, they're not equal. If they were equal, it wouldn't be moving. The up force is not greater than the other, so that can't be. So now I'm down to these two. Well, a second ago, I just said the normal force is less than 20, so I don't think it's A, but I'm going to go ahead and solve and figure out what it's supposed to be, because I need how many down and how many up. Well, how many up? That is only the force of friction, right? And so if that's the force of friction, that is this little side leg, just a small leg from the normal force, is giving me that vector, that component that I need. And so that, I already know that this hypotenuse is 2 kilograms. And so I need to find this over here. It is a 30, 60, 90 triangle. So this is a 30 degree up here. And I'm just going to call this X. What I'm looking for is X. So it looks to me like I have a sine problem. Sine of 30 is equal to opposite over hypotenuse. And that's not a 2, that's supposed to be a 20, right? Okay, so now if I go to my calculator and I take 20 times the sine of 30, that's going to give me my answer. And so we have 10 newtons going down the plane, but remember that we only have an acceleration of 2 meters per second squared, and we have a mass of 2 kilograms. So let's go ahead and figure out, okay, so force is mass times acceleration. The mass is 2 kilograms, and the acceleration is 2 meters per second squared, so that is 4 newtons. So in other words, we have 10 newtons going down the plane, but yet we have 4 newtons in friction, so I'm left with a 6 newtons left. 6 newtons going up the plane. Okay, let's look at number 4. We actually did one similar to number 4, I think, in that AP workbook. But let's take a look at it. So if we have this force pulling this, remember this force is pulling 3 kilograms. And then let's just call this force in here, let's just call it T. Well, T is only pulling 1 kilogram. So the question says, when a frictionless system above it is accelerated by applied force of magnitude, the tension, that should be magnitude F, the tension in the string between the blocks, that's what we are calling T. Well, this one's only pulling 1, this one's pulling 3, so it's only 1/3 of the force. Okay, number 5. A block of weight W is pulled along the horizontal surface at a constant speed V by a force F, which acts at an angle of theta, with the horizontal as shown. The normal force exerted on the block by the surface has what magnitude? Okay, I'm going to go down to a free body diagram. We have the force of gravity, right? We also have this force that is pulling it. Notice, of course, this force has the components, and I didn't draw mine perfectly, but the normal force we know is acting upwards. The question is how much upwards? Well, this is in equilibrium. In other words, it's not levitating, right? So in other words, I'm going to call this little blue dotted line my F sub x. So in other words, F sub x plus the normal force has to equal up to the gravitational force. That pull is making it less. The fact that it's pulling up a little bit is making the normal force less. So it is not greater than W, that's for sure. It's not equal to, because there is a pull on it. It's not 0. It's greater than 0, but less than the weight. Because that force that's being pulled is pulling it up just a little bit, and it's creating a lesser weight than the other one, than a lesser normal force. Okay, number 6. I don't really care for number 6, but we'll talk about it anyway. The reason I don't care about it is they've changed. Like all of a sudden they throw in weight, and they didn't have that before. So we have a rope that actually is thick enough that it has a weight to it. Usually we talk about strings that don't have any weight. So this has a weight to it. How much weight does it have? It has 50 newtons. And then we have a box down here that is 100 newtons. What is the tension in the rope? Okay, what they are trying to get at is like if you investigated this little bit of tension and if you investigated this little bit of tension, how much would each have? Are they the same? Well, they're not the same because this piece up here is actually carrying the weight of the rope plus the weight of the box itself. But this down here is only carrying the weight of the box. And so the answer is D, 100 at the bottom, 150 at the top. Now, I said I didn't like it because they threw in weight all of a sudden with a rope. I will tell you that the AP exam will do that sometimes. They'll throw in things that, all year long we talked about it this way, and now they're saying, well, what if it's not that way? So that happens from time to time. Unfortunately, it does. Okay, number 9. Okay, similar concept that we had a minute ago. A plane 5 meters in length, inclined at a 37-degree angle. A box of weight 20 is placed at the top and allowed to slide down. So here we have our weight, our force of gravity, and remember that that is the hypotenuse. So now when we draw our normal force, that normal force is actually smaller than the gravitational force. So in this case, we have a box of weight 20 newtons. So our gravitational force is 20 newtons. Well, our normal force is going to be less than that because it's at an incline. So it's less than 20, but greater than 0. Okay, number 10, multiple correct. And multiple correct are ones that, again, do appear on AP. People get frustrated by them, but they do. So 3 forces act on an object. If the object is moving to the right in translational equilibrium, in other words, the sum of the forces in the x direction is still 0. So that's what that means, translational equilibrium. Even though it's moving to the right, it does have a velocity, but it does not have an acceleration. The sum of the forces is equal to 0. So which must be true? The vector sum of 3 forces must equal 0, All three forces must be parallel, the magnitude of the three forces must be equal, the object must be moving at a constant speed. Well, it is a constant speed because it is in equilibrium and it is moving. And we just talked about that one a second ago. They have to add up to 0.